Right, then the last thing we're going to look at here today is to put masses to these. And so we're going to use the same chemical equation again. N2 reacts with H2 to yield NH3. Except now, we'll say this. If you go in the lab and take measurements, you don't make your measurements in moles, you make your measurements in grams. So we need to figure out how to do this with units of grams because that's how we actually measure. So let's do this question here where we say this. What mass of NH3 would be produced when 57.4 grams of N2 reacts with an excess of H2. Now I know that wording is sometimes a problem for some of you. You look at some of these problems and they'll say, wow, I don't know what to do. And many problems are going to be worded where they have this excess of something in there. And what I want to tell you here is don't let that excess of something confuse you, because what this is saying is when we carry out this reaction, if we go back to our sandwich example, if we wanted to make 40 sandwiches and we had our 20 slices of bread, let's say that we had like a big stack of, we're all going to be carnivores today, big stack of ham. Okay, if you have an excess of ham, that means we have no problem making all of the sandwiches. Okay, we have no problem making the sandwiches. So this is the same thing. Think of this as the bread, and this is that huge stack of ham. We have a way excess of it, so we don't need to worry about it. We can still make 40 sandwiches if we have a whole bunch of ham, is what this is saying. So that means then we'll ignore whatever this excess is. It does not pertain to us in the calculations, just telling us we have plenty of it to use up all of the nitrogen. So we then write out the problem. We start with the 57.4 grams of N2. And we're looking for which stuff in this one?
NH3.
NH3. Specifically, which units on NH3?
Grams.
Grams, because we're looking for a mass. So we want to know how many grams of NH3 would we be able to make. So then we can set this up to calculate. Then we remember what these coefficients stand for in this balanced chemical equation. These coefficients stand for moles. But this here is in grams. So that means we need to first convert our grams into units of moles. And so to convert from grams to moles, we need to use a conversion called a molar mass. Good. And then we want the molar mass of which stuff? Which stuff? N2. Remember, molar masses are always the grams in 1 mole. So how do we calculate the molar mass?
A periodic table.
We go to the periodic table and we look at nitrogen. Well, it shows 14.01, but how many nitrogens are in this formula? 2. So that means the molar mass is
28.02.
28.02 grams of N2. We then put in grams of N2 on the bottom, which of course again is 28.02. On the top we put in
1 mole.
1 mole of N2. We put this conversion in like that so we get the units to cancel out. Well, now we have moles, specifically moles of N2, but we're looking for NH3. So that means we need to convert from N2 over to NH3. And to convert from one substance to another, we need a conversion called a molar ratio. And specifically, which molar ratio do we want?
N2 to NH3.
Right, we want to relate these two because those are the two that are in this equation.
So 2 moles of ammonia would be on top and 1 mole of N2 would be on bottom.
Exactly. And why do we put it in that way?
Because then the moles of N2 will cancel out and you'll end up with ammonia.
That's correct. So we always select which ones we put where based on how the units will cancel out. So again, this is your molar ratio. Well, now we have moles of NH3. We're trying to get over to grams of NH3. So to convert from moles to grams, not Avogadro's number, we need the molar mass, right? And the molar mass is always the grams contained in?
An element.
Yeah, it's the grams contained in 1 mole. Molar mass is always the grams in 1 mole. So which molar mass are we going to calculate here? NH3, good. So to find the molar mass of NH3, we come back to the periodic table and we need how many nitrogens?
1.
And how many hydrogens?
3.
3. So we add those up. 14.01 plus 3 times 1.008. And we get
17.03.
17.03. So where does the 17.03 go? On the top. Grams of NH3. Where does the 1 mole go? On the bottom. And why do we put it on the bottom? Cancel out those units. So then what we do is we have this all set up to solve. We take 57.4, multiply that by 2, multiply again by 17.03, and we divide that by 28.02. How many significant figures do we want in the answer? We want 3, so it'll be 69.8 grams of NH3 for the answer. Any questions on this particular problem? Okay, well, we only have 3 minutes left here. Since there are only 3 minutes left, we'll let this one be optional to you. Here's the balanced chemical equation. You'll see your choices for the answers. So we'll check it out here. Wow, 100%. How about that? Good. So you don't even need to see me how to do it, right? V2O5. 1 mole V2O5 for every 181.88 grams of V2O5. Then we need the molar ratio, which would be 4 moles of V for every, what is it? 2 moles of V2O5. These units are going to cancel. And then our last conversion here is going to be times the 50.94 grams of V for every 1 mole of V. And once we run that through, it's 0. I don't even remember now. 169? All right. Thanks, guys.